My life is a lie. Are you getting that? Man, I can watch Kudos photosynthesis. Wait, I am back? Hooray! I am no black paper, still grounded. How? Hey guys, me. Yeah, and I'm watching photosynthesis on this. No, I do not want to go to the photosynthesis. Let me watch too. No, we're going to watch photosynthesis. Let me watch Rupert now. Back to the rubber do it again. Then we go to the principal office. Understand?
You may have heard it said that plants make their own food, but have you ever wondered how they can do that? The answer is a process called photosynthesis. The word photosynthesis is made up of two parts: photo, which means light, and synthesis, which means to put together. Therefore, the word photosynthesis means to put together with the help of light. Through photosynthesis, plants can convert energy from sunlight into the chemical energy that they use to fuel activities like growing and producing seeds. In order to perform photosynthesis, plants need three basic things: sunlight, water, and carbon dioxide. Plants convert these parts into starches and sugars and give off oxygen. Now that you know what photosynthesis is, let's take a closer look at how it works. First, the plant takes in sunlight. This process happens in the leaves and other green parts of plants, and it's all thanks to some special structures called chloroplasts. Chloroplasts contain a chemical called chlorophyll, which is what makes plants green. The chlorophyll is what absorbs the energy from
the monitor list. Are you ready? Okay.
In this video, we are going to talk about how to calculate the theoretical and percent yield of a compound. So the first thing we need to do is write a balanced chemical equation. So we have C3H8, which stands for propane, and it's burned in air, so it's going to react with oxygen gas, and it's going to produce carbon dioxide, and the other product is water. The reason being, it's a combustion reaction. You always get CO2 and water as products. So now we got to balance it. Whenever you want to balance a combustion reaction, you want to balance the number of carbon atoms first. We have 3 carbons on the left, so we're going to put in 3 in front of CO2. Next, we're going to balance the hydrogen atoms. So we have 8 on the left, 2 on the right. We know 4 times 2 is 8. And then finally, we need to balance the oxygen atoms. We have 6 oxygen atoms in the 3 CO2 molecules, 4 on the right from H2O, that's 10. 10 divided by 2 is 5, so we need to put a 5 in front of O2. So now the reaction is balanced. Okay, let's make a list of what we know. We have 30 grams of propane. Now, it's burned in air, so we can assume that we have an excess amount of oxygen. Whenever you have two reactants, you need to identify what's the limiting reactant and what's the excess reactant. You always want to use the limiting reactant to calculate your theoretical and percent yield, never the excess reactant. Now, the equation for percent yield, it is the actual yield divided by the theoretical yield times 100%. So you need to know the difference between the actual and the theoretical yield. The theoretical yield is what you calculate. It's the maximum amount of product that you can get. So if your reaction is 100% efficient, the amount that you get is the theoretical yield. In actuality, you never get 100% yield. It could be 80%, 70%, it's never perfect. The actual amount that you get in a reaction, that's your actual yield. So the actual yield is usually given to you in a problem unless they want you to solve for it. And the actual yield usually is the grams of product. You see how we want to find the percent yield of CO2? That means that we need to use the actual yield of CO2 and the theoretical yield. They gave us the actual yield of CO2. They said, 70 grams of carbon dioxide was produced. That's how much we actually got in the experiment. So we know the actual yield. What we don't know is the theoretical yield, the most that we can get from the experiment. So let's calculate the theoretical yield, the maximum amount of CO2 that is possible to get. So we're going to start with the 30 grams of propane. We're going to see how many grams of CO2 can be produced at most from 30 grams of C3H8. So let's start with 30 grams of C3H8. The first step is to convert to moles using molar ratio. So the molar mass of C3H8, which we get from the periodic table, it's about
Class, did you like the video?
The video was great. Leaves are so cool. Raphael and I liked the video.
This video sucked. You are a horrible teacher, and you should get fired by our principal. The video was crap. Let us watch South Park, Family Guy, American Dad, Robot Chicken, Bob's Burgers, and not a video about photosynthesis. Nor any baby shows such as Barney, SpongeBob SquarePants, Bubble Guppies, Sesame Street, etc.
I need to say serious, sir. Yes? What did you say? Yes, sir. Serious, sir.